If you're looking for a content explaining what is Vector and what is the difference with the other agents of the market, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is going to be part of the Open Telemetry and Community series where we covered lots of episodes. If you paid attention, I recently released several episodes dedicated to observability agents like the one on FluentBit v3, the one comparing FluentBit and the collector, and moreover. After releasing the episode comparing FluentBit against the collector, several people from our community has reached out to me asking me to consider comparing those agents with Vector. So today's episode will be focused on presenting Vector and looking at the various features and plugins. And I will also take advantage on working on Vector to run few tests to be able to compare it with FluentBit or with the collector. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you're going to learn out of this episode. We'll start by explaining what is a Vector. Then we will explain the design experience of building a pipeline with Vector. We will look at the receivers, so sources for Vector, for logs and metrics. We'll look at the transform plugins, so the processors, and you'll see that we will have a dedicated sections to the Vector Remap language that is provided by Vector. We will look at the sinks, so the exporters of Vector. We will look at the observability data provided by Vector. And last, at the end, on the conclusion, I will share a few comparisons with the collector or with FluentBit. Vector is another open source agent built by Datadog to collect logs and metrics. Compared to the other agents of the market, Vector has been built in Rust, so there is a big chance that the resource usage of Vector will be closer to FluentBit, but we will look at this in the conclusion. So what makes Vector different from the other agents of the market? Well, we'll see it later. The processing of Vector is really interesting, especially when using their transform language, VRL, Vector Remap Language. But why naming it Remap? Well, this is another story. VRL is the OTTL, Open Telemetry Transform language, built by the Open Telemetry community for the collector, but here it's going to be for Vector. The other advantage, but I will talk it later, is the observability data provided by Vector. Otherwise, to be 100% clear, Vector is not supporting traces, but only metrics and logs and events. But events, at the end of the day, is technically a log. You may say, another agent? But why? Well, it's clearly true, but just by looking around us, we have lots of agents. We have the Open Telemetry Collector, FluentBit, his big brother FluentD, Stanza that he's clearly not used anymore since it has been donated to by ObservIQ to the Open Telemetry Collector community. We have Promptail, the agents built by Grafana, and even we still see out there a couple of Logstash. So similar to all the agents of the market, Vector provides its own data model for logs and metrics. All the data collected will be structured respecting their own data schema. So when building a Vector pipeline, it is crucial to understand the schema to apply the right changes to our data. For logs, we would have a format like this. So we have a timestamp, a message that will be the actual log line, and then for each attributes that are in the logs, it will be added in the JSON payload. For metrics, it's going to be similar. So here we have the payload with the name of the metric. We have a JSON object called tag, and this will be all the label of a given metric will be under that objects. And then we have another object called for the metric type, so counter, gauge, histogram, and so on. And within that object, we'll have the values. And of course, the timestamps of the given value. Once you understand the data model, you can then start processing the logs, event, or metrics. In terms of processing, we will look deeper in this feature in the dedicated sections of this episode. Similar to the other agents of the market, we can either deploy it in a bare metal environment. It supports Windows, Mac, and Linux. It also supports Docker environments and, of course, Kubernetes. In terms of deployment, there are no major revolution because you could either deploy it as an agent. So in bare metal environment, it means it will be on the same hosts than our applications. In Kubernetes, agent mode means a daemon set deployment to be able to read all the logs from our cluster. Or we have the aggregator mode that is similar to a gateway deployment provided by all the other agents of the market. Gateway deployment means that you have one or several instances of your agents that will receive data and then push to our final destination, to our Observability backend. Aggregator mode would mean in Kubernetes to be either a stateful set, or in a stateless deployment, it could also be a simple deployment. Again, we usually don't have one agent deployed. We usually change the agents. Why? Well, first, it's just to simplify our pipeline. And then the other reason is the ownership. The project team could deploy their own agents close to their application to do some minor transformations. And then we'll have a larger agents managed by the central Observability team. So the model, with this model, it would split the ownership of the pipeline files. Similar to the other agents of the market, Vector relies on a configuration file. It's the pipeline that will go through specific steps. So first, as usual, we'll determine what we're going to collect or to receive. This step is named sources in Vector. In Fluentbit, remember, it's input, and in collector, it's receivers. Then we go to the step where we will process our data to enrich, to delete things. In Vector, this step is named transform, while in Fluentbit, it's named parser and filter, and in the collector, processors. And last, we define where we want to send this data. So this is named in Vector sinks, in Fluentbit output, and the collector exporter. Each individual steps, plugins of our pipeline will run in a separate thread. At the end, it's quite similar to the other agents, at least for Fluentbit and the collector. There's another interesting feature that is also part of Fluentbit. It's the hot reload, simplifying our maintenance journey. So if we have a change in our pipeline, we don't need to restart. We can just send the hot reload signal, and the agent will start picking up the new pipeline file. The other interesting thing to mention is that Vector has an API that could be enabled to expose a health endpoint. This brings my intentions. I'm wondering how I would be able to take advantage of this feature, because it seems very interesting, and I'm pretty sure that we can do lots of things with GraphQL. Vector can achieve most of the tasks that we expect from an Observability agents, but there's one thing that I think we need to be improved. It's the open telemetry support. Vector has an open telemetry source to receive logs using the open telemetry format, but it doesn't support metrics. And the biggest disappointment is related to the exporters, the sinks. Vector doesn't have any open telemetry sinks, so there is no way of exporting our logs or metrics using the open telemetry. It's quite surprising, especially when if you look at the open standard, open telemetry, that is clearly used by everyone in the industry and every solution supported. If you had an open telemetry sync, it would be much more easier to export our data to any of the backend of a choice. And the most surprising thing is that the Vector community has open issues on this open telemetry support, asking for this, but nothing has moved into that direction. The pipeline experience of Vector is a bit similar to Fluentbit. It has three design formats possible. So we have YAML, JSON, and TOML. TOML will be very close to the old Fluentbit design experience. So here is an example of a pipeline defined in a TOML format. So every sections of our pipeline will start with a section to say what type of plugin we're using, so source, transform, sinks, and so on. The ID of the plugin, so the name that we want to give to that section. And then within this section, we'll say the type of the plugin, so which plugin we want to use. And then, of course, we have all the properties of a given plugin. I personally have experienced more the YAML design that was also very close to the Fluentbit experience. So here's an example of a YAML structure, YAML design. In this example, we can see that there's a source sections, there's a transform sections, and the six sections. If you pay attention to this example, each plugin has a property named inputs. Inputs are making a reference to the ID of the plugin that will send the data to this plugin. In Fluentbit, this logic is a bit similar, but using tags. So in the input section, you put the tag name, and then when you do the parsing, the filter, you use match to see what type of data will be treated by this plugin. In Vector, this logic of inputs reminds me a lot of the design experience used by Stanza. So if you want to have more information about Stanza, check the episode about Stanza. So at the end, it will be through the inputs that you will define the actual flow of your pipelines. For example, if I want to collect logs from Kubernetes, do some transformations, and then send it to Dynatrace, I will define the following pipeline. So here's an example. With the input section in this example, you can see that it determines which plugin is going to send us the data in this actual plugin. The other amazing thing with Vector is the way we're going to design and debug our pipeline. The CLI has by default validated options that could control that we don't have any syntax issues in our pipeline. Then you will see later when we cover the vector transform language, it provides a playground URL where we can help to test our complex VRL scripts. And I think that is awesome to simplify our design experience and make sure that we understand our issues and resolve them in a very quick way. Vector provides a full set of plugins for each steps. Because of its nature, we should expect all the right plugins to receive metrics and logs with the most common sources. So for logs, we have file reading, a traditional file. We have Kubernetes logs designed to collect the logs available on our Kubernetes nodes. Fluent to receive logs from a Fluent agent. We have syslog. We have the Vector. Vector has its own protocol to basically send data between Vector agents. We have sockets to receive logs either through TCP or UDP. We have Kafka, Splunk, Logstash, Journald, Heroku, and OpenTelemetry. Similar to the other agent, it also includes a specific plugin for cloud provider like Amazon S3, Amazon SQS, Amazon Kinesis for a house. Two plugins that I thought was really interesting. It's the DNS tab to collect logs from DNS tab server compatible, and an exec plugin where we can build a shell command on the host of our agents to collect the output of those commands. And then we have a plugin for metrics. Of course, Vector provides the traditional plugins that we expect. So Prometheus support with the remote write plugin, the Prometheus scrape. We can also collect metric from StatsD. And then we have specific metrics plugin for Nginx, Apache, PostgreSQL, MongoDB, and of course, all the Amazon's ECS metrics, even StoreDB metrics, and so on and so forth. Of course, Vector has also a host metric plugins to get the metrics from the local systems. But in terms of metrics, it is currently not supporting OpenTelemetry, which is in our case a big limitation. Other metrics and logs, it supports events, which is technically a log. Similar to FluentBit, Vector provides specific plugins to collect the metrics and logs from our Vector agents named internal metrics and internal logs. So let's look at the two main plugins that make sense for our use case, which is Kubernetes. So we will look at the Kubernetes logs and the Prometheus scrape. Prometheus log is by far the simplest source in Vector. The challenge is more on the deployment requirements. Kubernetes logs will, of course, deploy Vector in an agent mode. So in a cluster, it will be running as a daemon set. Then we need, of course, to mount the folder to collect the logs, so var log pods to Vector to be able to read all the logs from the nodes. Kubernetes logs include several options to either filter a specific file name, apply a namespace selector, or a node selector, or even a label selector to collect only logs from specific pods, matching this label selector. This also means that Vector would require a specific RBAC to be able to list, get pods, get namespace from our cluster. What is very interesting with this plugin, it's not only reading logs, but also adding all the Kubernetes metadata that we need. Our logs will add the Kubernetes objects holding the Kubernetes metadata, the labels, the annotations of the logs produced by given pod. So at the end, no need to do any enrichments in our Kubernetes logs in the transform steps. That is a great news. The other plugin that we would probably going to use is Prometheus scrape or even remote write, but let's look precisely to the feature provided by the Prometheus scrape. So here the experience is a bit similar to FluentBit, where we need to list the endpoints that we are planning to scrape. So we need to define the actual path, so HTTP, the host name, the port, and slash metrics, or the path of your metric endpoint. It also adds options to manage the notifications if your exporter requires any notifications. But what I was a bit disappointed is that the Vector is not supporting scrap config, so no way of reusing scrap configs or even define relabeling config directly at the plugin level. But not a big deal, because you'll see later Vector has the right transform to properly process our metrics. When processing logs and metrics, we clearly expect to have specific plugins helping us to filter our data, parse our logs to extract extra details, reduce the cardinality of a metric by removing labels or even dropping unuseful metrics, batch the data to avoid facing API rate limits when we're exporting our data to a backend. So this is going to be done with the throttle plugin. And there's also something that is quite similar to FluentBit. There's an option to create your own EULA scripts. Very surprising. Well, Vector has a limited set of plugins to transform, but they are clearly all answering to all our needs. And even better, he has few plugin helping us to control the volumes of data. For example, you have plugins for metrics like aggregate, to aggregate the metrics and reduce them. We have cardinal limits to limit exporting metrics having insane cardinality. And you also have smart plugins for logs like reduce, collapse multiple log lines into one single log stream. There is a sample to sample events based on specific conditions. We even have plugins to transform our logs into metrics, or the opposite, to transform metrics into a log. But let's come back to our main use case. What are the plugins that we will answer to our needs? Well, there is Remap and there is Filter. Those two plugins will rely on the Vector Remap language, so VRL. You will see that it has many use cases to process our logs, but also our metrics. VRL is a programming language dedicated to process logs and metrics in a performant way. As of now, there are few transform plugins relying on VRL. So we have Remap, routing, and filter. The important aspect with VRL is that it will deal with our data as a JSON payload. It will provide several functions helping us to add new metadata, delete keys with del, remove a record by using remove, parse, and there are lots of ways of parsing functions. We have also convert, ability to convert some data, to decode, encode, encrypt, decrypt. So a lot of great functions. Similar to any programming language, you can create a logic using if, then else, for, while, until, so very similar to a normal programming language. VRL also includes a set of error codes, helping us to understand why we're having a specific issues in our code. It will help us to build more reliable VRL scripts. In case of a parsing issue, we can get the error code and react based on the error returned. So I won't list all the error code, it would be just a waste of time. So here is the link to the documentation listing all the error code available in Vector. When using VRL, we will utilize the data of our pipeline. Like explained previously, the logs and metrics at the end will be treated as a JSON payload. For example, if I want to create a new field called content with the value of an existing field called message, I can simply create the following instructions. Here, .content equal .message. Or even if you think about message could be a JSON payload, and within that payload there is an attribute that holds the message. I could even do the similar things here, .content equal .message, and then the property that holds our line, so text message in our case. VRL is not a complicated language. In the opposites of OTTL, we have the options to create variables in our VRL scripts, which makes the maintenance much more easier. Like briefly explained, it also have the right functions to parse texts, JSON, and even have predefined parsing functions for Apache, Nginx, Syslogs, and way more. Let's say I want to enrich my Kubernetes logs using the metadata provided by default by the Kubernetes log source. Here is an example. This will rename the various Kubernetes metadata exposed by Kubernetes logs to the standard naming convention. It will extract from the pod owner the workload kind and the workload name, and then I'm resetting new attributes called DT Kubernetes workload kind and DT workload name. This is also using a regex parser to parse the file name to extract the pod UID. So at the end, you can really enrich data in a very easy way. VRL is not limited to logs, but we can also reduce cardinality by dropping labels the VRL. For example, here I'm deleting container ID and PID from the metrics if the labels exist in the metrics. The other thing that I really loved with VRL is the fact that Vector provides a playground URL, helping us to test our VRL scripts, to debug them. So it is clearly something missing in the OTTL in OpenTelemetry language. So here is the URL to reach out to the playground. At the end, I think Vector provides lots of options to probably process our logs and metrics. One thing that I have not seen in Vector is the options to convert cumulative metrics into Delta. This is clearly something missing that could bring extra value to the metric processing. It has lots of destinations like the HTTP to interact to any API ingest endpoints, New Relic, Syncs, Honeycomb, Humio, Mesmo. And we can also send to Amazon Logs or CloudWatch for the metrics, S3. We also have Azure for metrics and logs, GCP, logs and metrics. We have StatsD, Prometheus, and more. But like mentioned in the introduction, it is very, very disappointed that Vector is not providing the OpenTelemetry sync to send metrics and logs to any Observability backend supporting the open standards. One thing that Vector is excelling is the observability. It has two internal sources, so internal metrics and internal logs. Internal logs will add the logs of the agents in the Vector pipeline. It is great because we can then keep track on the potential errors to collect or even export the data to a backend. And more than that, we can get the reason of this error and resolve the problem in our pipeline. But the impressive thing is the number of metrics provided by Vector. I won't describe them one by one, but you can clearly understand how many records is coming in and out of a given steps and even on a given plugin. It also provides clear indicator on the behavior of the buffer of each plugin, very useful to avoid any memory pressure events. And last, it provides a utilization metric showing the CPU load for each individual plugins and steps of our pipeline. In case of high CPU usage, you can understand where you're spending most of your CPU and which part of your pipeline should be optimized. I think this is clearly very, very powerful. So here is the link to the metrics provided by Vector. That's it for today's episode related to Vector. Vector, as you understood, is an agent that is mainly designed for collecting metrics and logs and events. It has lots of interesting plugins and lots of exporting features. The only downside of this, like I mentioned several times, is it doesn't have the way of exporting the data to the open standard OpenTelemetry. So please, Vector community, work on this, add the syncs for OpenTelemetry, so then you can export it to any backend of the market. It will be much more smoother, easier for everyone that wants to use Vector. The interesting piece, I think, from a Vector perspective is the processing. VRL, the first impression was, okay, another language that I need to learn, but at the end, the onboarding is very easy. The fact that there's a playground, it makes the design experience much more easier. And then because it's a very common programming syntax language, it's very easy to start building your transform or modifications using VRL. So I think VRL is very powerful, and all the required functions that we'll need to do any transformations or dropping or whatever you want is actually there. So big thumbs up for the processing aspects of Vector. The other interesting piece in the transform, I really be very impressed by this, is all those plugins that will help you to control the cardinality of the metrics, to reduce the number of logs, to aggregate the metrics. So there is a lot of free options here and there to control how many data you want to send to your backend. So this is also a very interesting point that I never seen in Fluentbit or never seen in the collector. I see with the collector you have the sampling, but more for the traces aspects. In terms of resource usage, so I did some couple of tests, the similar one that I've run for the collector or for Fluentbit, so the ramp up test and the soak test, so 24-hour tests. What I've seen so far is that the CPU usage and the memory usage is close to the collector. So we're about 100 megs to 200 megs of usage in Vector, depending on the load that you apply. And the CPU resources is also very much more higher. So again, if we need to compare the agents, I would say Fluentbit is by far the most optimized agents of the market in terms of memory footprint and CPU footprint, because you consume 30 megs or 40 megs, and in Vector, once you start dealing with metrics and logs, you're more closer to 100, even more to 100 megs of CPU usage. So at the end, if you need to deal with metrics and logs, again, you will have to choose between Fluentbit and Vector. They all have the similar features, I would say. Vector, maybe the design experience is a bit nicer, but in terms of resource usage, Fluentbit is clearly the main player that you could pick. The collector, again, if you need to deal with traces, of course the collector will be there because Fluentbit is not supporting it properly. And last, Vector is not even supporting traces. So collector will be a clear choice when you have to deal with traces. All right, so if you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. Bye.